we're going to take a look at some applications of quadratic equations. So the first thing we're going to do is take a look at this review. Write the equation of a quadratic, and we're given our vertex, and we have a coordinate. So we'll start by writing this in vertex form. So that was that y equals a x minus h squared plus k, where h and k were our vertex. So we can fill in the blanks. Y equals a x minus 1, so plus 1 squared plus 8. Well, now we have this other coordinate to plug in, our x and y. So our y value is 5 because we need to solve for a. 0 plus 1 squared plus 8. So we have 5 equals 1a plus 8, subtract 8. So we have negative 3 equals 1a. So there's our a value. So our final equation is y equals negative 3 x plus 1 squared plus 8. So this is our vertex form. If we needed to write it out to standard form, we would simply take this and we would expand it. So if we distribute here, we got x squared plus x, distribute the 1, plus x plus 1 plus 8. So negative 3 x squared plus 2x plus 1 plus 8. Negative 3x squared minus 6x minus 3 plus 8. And combine like terms, negative 3x squared minus 6x plus 5. So this would be in our standard form. So today, though, we are going to start taking a look at some word problems. So the first one we're going to take a look at. A farmer wishes to enclose a rectangular garden with 100 yards of fencing. Okay, so if the garden is x yards wide, find the length and area of the garden in terms of x. Well, so we know this is x and x, since it's a rectangle, but we have to figure out these two other sides. So let's see here. Well, if it's 100 total, we've subtracted 2x, x and x, and it has to be equal between these two sides, so we divide by 2. Let's see, so that's each side would be 50 minus x. So we end up with the area equals x times 50 minus x. The second one, find the width of a garden with an area of 525 yards. So we know our area, our x times 50 minus x equals 525. And now it just becomes a quadratic to solve. We have 50x minus x squared equals 525. And if we solve for, we'll set it equal to 0 first. Let's see if we add the x squared, subtract the 50x. We have x squared minus 50x plus 525 equals 0. And it's up to you the method to solve. You could do quadratic equation, completing the square, or you could attempt to factor. And if you solve any of these methods, so let's pause it, see if you can solve it, you should end up with x equals 15 or x can equal 35. Now this next one here, the height of a ball t seconds after it is thrown is modeled by this function. Find the maximum height it reaches. So if we're talking about the maximum here, we know that this is a quadratic going down looking like this. So here's our maximum, that would be the vertex. So I'm going to write this in standard form here, negative 4.9 t squared plus 24t plus 1. So our x-coordinate, or in this case our t-coordinate, the time, is the opposite of b over 2a. So we have negative 24 over 2 times negative 4.9. And that ends up being 2.45. And if we plug that into our height equation, so our height is negative 4.9 times 2.45 squared plus 24 times 0.45 plus 1, we end up with a height of 30.4 meters. Now the second one here, for the length of time will the ball be higher than 20 meters? So when we think about this parabola here, if here's our height of 20, it's going to be above the 20 meters right here. So we'll set it equal to 24. So 24 equals, it'll be a few minutes, 24 equals negative 4.9 t squared plus 24t plus 1. 24, I don't know why I said 24, that should say 20.